So let's see, the first example, find an equation. This is really just a basic exercise where we need to find an equation of a plane passing through a point. The point is 2, 4, and -1 with a normal that is 2, 3, and 4, the vector component of the normal. Okay? And also what we need to do is find the plane intersect and sketch it, or sketch the plane. What I mean by plane intersect is the plane intersect with the different axes. So the x-intercept, y-intercept, and z-intercept of the plane. Okay. That's what we mean by that. So let's start with what we know. Well, we have the normal. So the normal are the component A, B, C. In this case, those are given as 2, 3, and 4. We need a point, P sub 0, which is x sub 0, y sub 0, z sub 0. So those are 2, 4, and -1. And now all we need to do is go and write it in this equation. Okay, so we have 2 4a times x minus 2, x sub 0, plus the other direction number is 3 times y minus 4, and the last direction number is 4 times z plus 1, and all of it equals 0. Okay, and this is good enough an answer. If we want the linear equation, this is the scalar equation. The linear equation we just multiply it out, so you have 2x plus 3y plus 4z, and the three coefficients are -4 and -12. That will be -16 plus 4, so it will be -12. So we can write it as -12 equals 0, or simply, actually, let me be consistent. So we'll write it as -12 equals 0, or Weber-Sand will accept this form, 2x plus 3y plus 4z equals +12. Either one is good. The left is the standard form, but both forms are linear. Okay, so this takes care of the initial requirement. Now we're going to go through the intersection. So what is the x-intercept? Okay, the x-intercept, we obtain that by setting y and z to equal 0. Remember, the x-intercept on the xy plane is the value of x when y equals 0. The y-intercept is the value of y when x equals 0. Here we have to have the two other axes to equal 0, and therefore it doesn't matter which one we're looking at, but if we look at this form right here, that's I think the most convenient form. If both y and z equal 0, you have 2x equal 12, and therefore x equals 6. Therefore, the intercept will be 6, 0, 0. Okay? So that will be the x-intersect. The y-intersect or intercept, likewise, will set x equals z equals 0, and we solve for z, so for z equals, the solution will be z equal 3, for z equals 12, z equals 3, so the point will be, I'm sorry, yz, set y equals, I start with y, jump to z, sorry. So if x in z equals 0, we have 3y equals 12, or y equals 4, and the intercept, the y-intercept will be 0, 4, and 0, like so. And finally, the z-intersect will set x and y to equal 0, and now we can say z equals 3, and therefore the actual point would be 0, 0, 3. On the next page, let's sketch it. And in order to sketch it, we need the x, y, z intersect, as you can see. Those are really great tools to try to attempt to sketch a plane. We are not going to sketch the whole plane, but we can take a piece of the plane. In this case, it will be a triangle. Okay, let me split so we can I can move on. So the next page, let's draw a coordinate system in x, y, and z. And on this coordinate system, I'm going to start drawing the intersect. So the x-intercept is x equals 6. 1, 2, 3, 4, 5, 6. So it's right here. The y-intercept is y equals 4. And the z-intercept is z equals 3. Okay, so a plane that's passing through these 3 points will be a good representation, or the triangle, the 3D triangle will be a good representation of the plane. So the coordinate of this point is 6, 0, 0. This will be 0, 4, 0. And right here we'll have 0, 0, 3, like so.